What is the machine?
The machine is actually part of a research agenda and an architecture of the future. So here at Hewlett-Packard Labs, we've been exploring what the future looks like, both in technology and trying to solve the problems that we see today and in the future for our customers in the IT industry. So we've been investigating architectures and various technologies. For example, right here we're looking at photonics, where we're looking at how the data inside your computer is moving around and how to make it faster and potentially separate it out so we can go over broader distances.
So how do you make it faster?
For one, what we're looking at is we want the memory to be the center of everything, not just the CPU. Right now, traditional architectures are really bound by the CPU, and the memory is both physically and virtually locked to the processor. We change the game with our machine architecture. We make the pool of memory the center, and then any processor or SoC, system on a chip, can access any byte in the memory. So we have large pools of memory that can be physically separated from the processor, but they need high-speed connections to be able to move bits. And then any SoC or processor in the system can access that pool of memory at a byte level, load store domain. With that, we also think that the technology of the future in memory is going to allow for a lot larger memory pools. So think today's Superdome X, I believe, ships 24 terabytes. We're talking hundreds of terabytes and eventually petabytes of data, all in your system from the first day. So you think of your enterprise database as having 100 terabytes, it's all in memory. It's not off on disk, you don't have to archive it. You can do operations and get faster time to insight on that data instantaneously because the data is right there.
Yeah. And you're using actually light.
Right, that's a key part. So light or photonics has several valuable pieces to add to the table. One is our bandwidth can be higher. So for example, we have a fun demonstration here wherein today to actually transport data, this is a copper traditional wire. What you could transport over here can in the future be transported over something this thin because of light. It also has some really other interesting characteristics where it is actually lower power and it runs cooler in the system. So power is a big problem in the data center today. Just keep growing the needs of power in the data center. This is one way we can reduce that in the future by going to different fundamental technologies of how we move bits around in a computer.
Yeah. So when will we actually see a computer with this?
Well, so some people say, I thought we already had optics today, I have it in my network. Well, we need to bring the cost of photonics technology down in order to make it into the actual enclosure of a computer or to interconnect multiple enclosures in one instance of the machine prototype. So what we've done with Hewlett-Packard Labs as well as some of our engineering teams we've developed the chip X1. It is our optical to electrical transceiver, and along with some of the integrated mechanical way that we bring together the chip and connect it, we are now on a path to have the price equivalency of copper and optics inside our computers. And that's really what's important, right? Because price is always important to our customers. So we've got some really innovative techniques here that we've used with some of our partners to scale down how you implement photonics today. And then ultimately we think the next generation is about doing photonics right off the silicon. So here at Labs we show you some of the physical technology that we're testing in silicon where we can actually modulate light with the silicon structure. So that's like the next generation where photonics will run right off the chip.